Logarithms are the inverse of exponentials. So exponentials and logarithms go hand in hand. Just one is the reverse of the other. So I've put some examples here. We know that the exponential 10 squared is equal to 100. So if we have a logarithm in base 10, so you can see here, base 10, and I've underlined it there, log base 10 of 100 is 2. So you can see how it's just been rearranged to be written as a logarithm. Then you can see that 2 to the power of 3 equals 8. So logarithm base 2, and again, I've underlined those. Logarithm base 2 of 8 equals 3. So the general rule is that if a to the power of x equals b, then the logarithm of base a of b is equal to x. So again, you can just see the things have been written in a different order. So the thing with logarithms is there's obviously all different bases. Logarithm of base 10 is the most common, and therefore it's assumed that if it's just written as log 100, that the base is 10, because otherwise the base must be stated. So if it is not base 10, then the base must be stated. So example 1, without a calculator, find log base 2 of 16, what that answer is. So what we can do is if we write it in terms of an exponential equation, the base is 2, we're going to have it equals x. So we're going to have x as our power, and then the answer to the exponential is 16. So we know that 2 to the power of x equals 2 to the power of 4, so x must be 4, which means log base 2 of 16 is equal to 4. So the next one is log base 4 of 8. So again, I'm just going to put it here equal to x. So I'm going to write it in exponential form. So we've got the base of 4 to the power of x equals 8. So I need to put them both in base 2. This is bringing back in our knowledge of solving exponential equations. So we need them both in the same base to be able to do that. So I'm going to do 2 to the power of 2x, because 2 to the power of 2 is 4. And I'm going to put 8 in base 2 as well, which becomes 2 to the power of 3. And now that they're both in the same base, I can ignore the bases and solve the equation to get 2x equals 3, which means x is equal to 3 over 2. Therefore, the logarithm base 4, 8, is equal to 3 over 2, or 1.5. So you can see here the last one for this example just says logarithm of 0.1. Now, because there is no base, it is assumed that it is base 10. So the first thing I'm going to write here, just for your notes purposes and for the purpose of this video, I'm going to write it out like this. So we've got log base 10. I've actually filled the 10 in. Of 0.1 is equal to x. So now I'm going to write 10 to the power of x is equal to 0.1. So now, again, same as the previous example, before I can solve an exponential equation, I have to have them in the same base. Now, 0.1 is the same as 1/10. So if I write 10 to the power of x is equal to 1/10, I can then know that 10 to the power of x is the same as saying 10 to the power of -1. Okay, so 1/10 is 10 to the power of -1. So x is equal to -1. Therefore, log of 0.1 is equal to -1. So that's just a really basic, straightforward introduction to logarithms and how they work, and that you need that good understanding of exponential equations and solving exponential equations to assist you with logarithms. It is also handy to know your basic powers. So, 2 to the power of 2 all the way to 2 to the power of 6, 2 to the power of 7, 3 to the power of 1 all the way to 3 to the power of 5, etc. You need to know those basic exponential equations, because that will help you a lot when you're doing these logarithms. I will just also add for this course, we only do logarithms of positive numbers. So in this case, a needs to be a positive number. Logs of negatives they can be done, but they involve complex numbers and they're beyond the scope of year 12 methods.